Thanks for the introduction. My name is Len Padilla. That was almost right. So what I'll be talking to today about is why hybrid is the title, and it's a bit about a personal realization, why hybrid is the way to do things, and hybrid isn't just cloud, hybrid IT in general, and then a few customer stories. So like you said, I'm the VP Product Strategy. It's not a very technical talk today. I ran operations and engineering for about 10 years at NTT. And I would have talked in technical terms then, but these days I'm focused more on how we can help our customers, what it is that they need to do, and what we can do for them. So who is NTT? Show of hands, who knows us? Who knows NTT? Oh, this is great. I don't usually get that many hands. I usually say that NTT is probably the biggest company that you've never heard of, because we're not a household name in Europe, but you can see the numbers here. I'm not going to read them all. Very large company, number one in terms of revenue, telecoms operator in the world, millions of, or hundreds of thousands of people around the world, and many, many different customers. Just a quick show of where we're located in terms of the countries that we're present in, the undersea cables that we either own or are part of a consortium that owns, the data center locations, and the office locations. So suffice it to say, we're a company that's got a lot of people and a lot of infrastructure in a lot of different places. The part of the company that I'm in is hosting and cloud. I've been with the company for about 13 years, and I've seen the entire journey, all the way from what we used to call shared hosting, dedicated hosting, managed virtualization, up to cloud computing today. So a slightly different kind of map. I came into IT in sort of through the back door. Wasn't a computer science major, wasn't an electronics engineering major. I actually studied atmospheric physics. And as many of you might know, atmospheric scientists were some of the earliest users of really heavy-duty computing. So the work that I did was modeling the atmosphere, and this is some of the kinds of work that I was involved in. The place that I worked was full of VAX VMS computers. Show of hands? Best operating system in the world? There you go. And it was a really great system. You could almost think of it like a private cloud. It was clustered, it worked together, you could submit jobs to it, it shared resources between different nodes, it was all networked together, so it did a lot of really great things. But what we learned, and this is back in the mid-'80s at this point, what happened to us in this environment was we had a team running these systems, our systems engineering team, that were very, very good on VAX VMS and didn't really know that the rest of the world existed. They were very, very focused on what they did. And that was very limiting for us. We realized early on that we needed to find a new way to use different kinds of computing. We were hearing about different things that were happening. We felt a bit isolated in our group, so we needed to look outside. Like anybody that uses IT, whether it's in a corporate environment or in education, the better the tools you have, the more things you want to do. For an atmospheric scientist, that means tightening up the grid size, running your models on a more fine time domain, and eventually, hopefully, getting better answers. I know that this happens within the enterprise as well. We get new software available to us. We try to do new things, and we have new efforts, new markets that we want to hit, new products that we want to launch. But what happens, we get better and better tools, but we don't always get more and more resources along with them. So we've got that challenge that everybody faces. We need to do more things with less all the time. And then came the machine that I'll admit blew my mind. One of our professors wrote into one of his grants a new Silicon Graphics Indigo Workstation. And this was a great tool for us. This allowed us to do some local visualization and local data analysis that we'd never been able to do before, on timescales that we'd never been able to do before, and actually animate things in 3 dimensions like we'd never been able to do before. It completely changed the way that we looked at our results. But on the compute side, this machine was very, very, very slow. It was very average when it came to actually running an atmospheric model. It was probably about as fast as one of the first Pentium computers. Wasn't very quick at all, but on the graphics side, it was life-changing. So we figured we needed a different way to do the compute side. We had the visualization covered, we had the analysis covered, but what about the compute? And for us, that was, for me personally, that's where the Cray 2 came in. So we started getting access to Cray supercomputers, either at some of the educational supercomputing centers, the National Center for Atmospheric Research. So we had a really great place where we could do all of the compute. Now this gave us great tools, but it greatly complicated as well the things that we were trying to do. We had one set of computers that we would run data pre-processing jobs on, another set of computers that we would run visualization jobs on, and a third set of computers that we would run the bulk compute, that we would feed the model and the data to and actually predict the behavior of the atmosphere. Hybrid. We learned early on that hybrid was really the only way that we could do this. We took the horses for courses approach. We learned that you need to put the right kind of workloads on the right kind of environment. And in the real world, we think that that's what cloud is. We think that cloud, at its core, is that automated, industrialized compute engine that we hear about, that we heard described earlier, that it has to be on demand, that it has to be pay-as-you-go, that it has to be flexible, it has to give you that agility. But in the real world, unless we're a brand new greenfield Silicon Valley startup, which probably not many of us in this room are, in the real world, we've got legacy compute to deal with. We've got, I heard somebody mention earlier, an AS400, or we've got a Z series or a P series sitting in our corporate data center somewhere. We need to find a way to stitch all of these things together. So for us, again, repeating is what cloud is, it's a combination of the corporate data center, maybe then things that only make it as far as co-location with a service provider, and in the end, what we call cloud. I think if we put all of those things together, that really is what we call the hybrid cloud. So the technology of all of this is interesting, but like it says here, what's important is knowing your estate well, knowing how you can take it apart and put it back together. We did a research article with Gartner about a year ago, and one of the main findings that we found was that many of the companies that we were dealing with, many of the companies that were surveyed, didn't really know their architecture well enough to be able to know where can different things sit. And it sounds amazing, it sounds trivial, but it's one of the hardest things for a large enterprise to do. And that's where I think service providers can help a lot, as well as helping with the infrastructure part. It's coming in and understanding what that journey looks like, having done it several times, and being able to help them identify which pieces of what they're doing are going to fit well in the public cloud, which pieces of what they're doing should never leave the corporate data center. And that's going to depend on a lot of different factors. So a few companies that we worked with, and I'll tell you a little bit about how they made the decision and what moved them when it came to moving workloads to cloud. So Company X, I hate doing this. I hate having to put Company X and not putting the real name. We're working on the release of a public case study with this company, and it's not ready yet, so I can't. They're a large global reinsurance company. That's what I can say. They've been working with us for quite a while. We had them in hosting before they moved into the cloud. And what they found, the key thing that moved them into cloud, it was actually very similar to my experience back in the atmospheric science days. They had really great systems and really great teams in-house to do the things that they were doing. But when they looked at cloud, when they looked at new ways of doing things, they realized that they didn't have those skills. They needed to find a way not just to have a new kind of infrastructure to work on, but really be able to take advantage of, take the benefit of the people that were within the service providers that they were looking at. So people and skills are one of the big reasons to look to moving into a hybrid with cloud. Another customer of ours, Criteo. What this company does is targeted advertising. They work with a lot of the online advertisers, and they help them analyze the data and target the advertising well. So what they needed was good global coverage. This was a situation where they're located actually in France, their headquarters is in France, but they work globally. They needed cloud not only for the agility, not only for the ability to use only what they needed. What they really needed was global coverage. They needed to be able to use identical systems and control them as one machine in Europe, in US, in Asia, in all parts of the world. So that was one of the key reasons that moved Criteo to the cloud. And Salesforce.com, everybody knows them. They've often been the poster child, whether it's SaaS or cloud systems. What they needed was compliance with certain regulatory domains. They had a lot of customers in Europe, and we heard somebody mention this earlier, that were asking, where's my data? And when they did give the street address of where the data is, which they were able to do, a lot of people weren't happy about that. They said, we're not happy having our data in the US. Primarily, the primary reason that they're not happy with it is they're not happy with the US government. They're not happy with the thought that that data could surreptitiously be read and they don't know about it. So having their data located in the continent that they're serving European customers was super important to them. That's why together with Salesforce, well, we built them a data center here in the outskirts of London. So when somebody comes to them today and asks, where is my data, they'll be able to give them an address that makes them much happier with the answer. So again, the split, how you end up splitting that IT resource, it'll depend on people and resources. It'll depend on the skills that you have in-house and the skills that a service provider, whether that's a cloud service provider or an outsourcing service provider, can bring to you. Location and distance. And the distance is usually the distance between the compute and the end user, trying to minimize that. In some applications, that latency is critical. So the ability to have a cloud that's global, to use that as the architecture that you build your application on, is very important. And the last one, security and compliance. Again, very, very important. When people are asking that very hard question sometimes for us in this industry of where is my data, being able to give them an answer that is in keeping with what their regulators demand. So where did we get this information? One of the things that we do a lot is surveys, research articles with our customers. Last year we did a research article that was, we called it Growing Pains in the Cloud. You can look at it on growingpainsinthecloud.com, or if you stop by our table here, we've got copies of it that we can give out as well. We asked 300, and I'll get to why that's 1,300, we asked 300 different CIOs, what are the things that are keeping you from moving into the cloud? What are the things that you know about that are holding you back? The number one thing that we heard from them was the complexity of their legacy IT. And this goes back to that question of a lot of companies, it's crazy, it sounds nuts, but not understanding their IT infrastructure very well, not understanding their estate, not knowing how they can take it apart and put it back together on a more modern platform. Now, the other 1,000 CIOs come from a second research article that we're doing, more focused on security. So we asked 1,000 CIOs, what are the impacts of everything that you know after the Snowden allegations, and how is that impacting what you put into the cloud? How does that change your decision making when you decide on cloud? And that's a research study that we've almost got ready. It'll be on Growing Pains in the Cloud when we've got it done, probably in a couple of months. So that's what I have to say about cloud today. Like I said, the most important thing is knowing the estate well, knowing how to take it apart, knowing how to put it together, and then recognizing that the pure cloud, that automated industrialized compute engine, isn't the place for everything. There are things that are always going to stay in your corporate DC, and there are things that are always going to, that won't make it any further than maybe co-location, while some things make it as far as the cloud. So I hope that's good information for you. I hope it sparked some thoughts. And again, if you have any questions about the Growing Pains study that we did, we're right outside and we'd be happy to answer your questions. Thanks very much.